students, hope all of you are well. So today I welcome all of you in the first video lecture regarding the unit 2 of our syllabus that will deal with the vector differential calculus. So in this lecture we are going to discuss about the gradient and its application along with many solved problems for your exam purpose. So let us start. So before we start the topic of the gradient, we need to know some basic definitions about two types of function usually we use in the vector calculus. First one is known as the scalar point function and second one is known as the vector point function. So what is a scalar point function? A real valued function f is said to be a scalar point function if for any point p in the domain on which the function has been defined, if we substitute the point inside f, this quantity will become a scalar quantity. So usually we write down a function as f of something. So in that place, if we substitute p, we should get some scalar value. Those type of functions are known as a scalar point function. For your example, here I have given one example of a scalar point function. So x square y minus xyz plus yz square. It is a function of three variable xyz which is defined over the real number. Now if we define the function like this, now if we substitute any point p, suppose the p point is having the coordinate a comma b comma c. This a, b, c are fixed values, so you can choose any value, a equal to 0, b equal to 1, c equal to 1 or any random value of a, b, c. While you substitute the value of a, b, c in the function f, it will create a scalar quantity a square b minus a, b, c plus b, c square, which is a scalar point. Now let us come to the next function that is known as the vector point function. So a real valued function f is said to be a vector point function defined over a domain D if we substitute a point p, a, b, c in the function. The f of p, this value of the function is going to be a vector quantity. So in place of the scalar, we are getting a vector quantity. So let us take an example. Suppose we have taken f vector point function xyz as xy square I cap minus yz square j cap plus xz k cap. So in place of x, y and z, if you substitute any point, then this quantity will give you a vector point function. So for example of real scenario, you can imagine pressure at a particular point, it gives a scalar point function, while velocity of any particle towards any direction, it gives a vector point function. Now we come to the first differential operator, that is the vector differential operator delta. So the first order vector differential operator is usually denoted by this symbol, that is del vector. And how to define this del vector? Del vector basically defined as an operator I cap del del x plus j cap del del y plus k cap del del z. We have defined this vector differential operator as a function of three variable case. Now if the operator will be defined for function of two variable, then definitely there will be no such k component. Then it will be I cap del del x plus j cap del del y. Since the order of these differentiations, all the partial derivatives are of first order, so it is a first order vector differential operator. Now let us come to the first application of the vector differential operator, that is known as the gradient. So what is the gradient of a scalar point function? Let us first define the gradient of a scalar point function. Let us consider a point function f of xyz, which is a scalar point function. This function must be a differentiable, that is, it must have the continuous partial derivatives of all the variables defined over a domain D. This function is defined over a domain D. Now the gradient of f is denoted by grad of f, or symbolically we write down it as a del f, and it is defined as del f. That means first of all we have to write down the del operator, I cap del del x plus j cap del del y plus k cap del del z. It will operate over f as a separate quantity. Since derivative, suppose if we write down d dx of y, we write down it as a dy dx. So whenever this operator will operate over f, the formula of grad f will come, and the formula for grad f is going to be I cap del f del x plus j cap del f del y plus k cap del f del z. So this del del x, it will wholly operator over full f. Del del y will operate fully over f, and del del z will fully operator over f. Now let us come to the physical meaning of this gradient at a particular point. Suppose we are having a scalar point function as f of x, y, z equals to c. So this type of function in the vector calculus, it is known as a level surface. So let us consider this level surface which I have drawn here, and right now I am shading this with the yellow color. So this whole surface is nothing but our level surface. Now suppose we want to find out grad of f at a particular point P. So what is the meaning of grad of f at a particular point P? If we draw a tangent through the P, and we can get the normal at the point P. So the normal at a particular point P of the level surface f of xyz equal to c is basically represented by this grad f. So what is the physical meaning of grad f? Simply we can say grad f at a particular point P, it will represent a unit vector to the surface at a point P, at a particular point P. Now we come to one of the application of the gradient. The first application we are going to learn, that is the directional derivative at a particular point. The directional derivative of a scalar point function f of xyz at a particular point P in the direction of a unit vector a cap is defined as df ds, that is equals to limit s tends to 0 f of q minus f of p upon s. What is the meaning of this? Suppose we are having a level surface, that is the one of the surface that I have drawn here, level surface is there. Now we are considering two consecutive points having the arc length between these two as s. So p and q are two consecutive points and having the arc length as s. And a cap be an unit vector which is crossing over the level surface toward a particular direction. Now if we want to differentiate this function f of xyz equals to c towards the direction of this unit vector a cap, this can be defined by df ds. That is the difference between the functional value at the two specific point or two neighboring points divided by the arc length, and we have to take the limit value s tends to 0. Now if we do some little calculation here, then the gradient value in terms of gradient we can calculate the directional derivative. So in terms of the gradient, what is the formula for the directional derivative? That is this df ds can be calculated using simple dot product, vector dot product, that is a cap dot product with grad of f at a particular point. So the students, if in your exam you are going to get any question regarding the directional derivative, what is the first thing you have to do? You have to find out the gradient of the function at a particular point. Then we have to calculate the unit vector to which direction we have to find out the directional derivative and make the dot product of the unit vector along with the gradient at that particular point. Now let us come to solve some questions regarding these concepts that right now we have discussed. The first question is find the unit normal vector to the level surface x square y plus 2xz equals to 4 at a specific point 1 minus 2 comma 3. It is quite easy to find out this, but before we find out, we have to consider a level surface as a function. So we consider a function f as xyz equals to x square y plus 2xz minus 4, taking 4 on the left hand side. Now we need to calculate the gradient of f. Why? What is the purpose? Because in the question they are asking for the unit normal vector, and from the physical meaning of the gradient we have learned that gradient of f at a particular point represents the normal vector to the surface. So we need to calculate the gradient of f. So we have applied the formula I cap del f del x, j cap del f del y plus k cap del f del z. So what is the partial derivative of f with respect to x? First term it will come 2xy. From the second term we will get 2z. So 2xy plus 2z into I cap. Del f del y, only in the first term y is there. So differentiation of y with respect to y is 1 and x square is constant while doing the partial derivative. So j cap component is coming along with x square. Now what is del f del z? That is equals to 2x. In a similar manner we get this. Now we have to substitute the particular point here 1 minus 2 3. So after putting the point at grad of f, we have calculated the value, and the value is coming as a 2I cap plus j cap plus 2k cap. So definitely 2I plus j cap plus 2k cap is not a unit vector. So we have to make this thing as a unit vector. And how to make this thing? That is grad of f divided by the magnitude of grad of f. So 2I cap plus j cap plus 2k cap divided by root over of coefficient square, that is 2 square plus 1 square plus 2 square. So we are having from here that is 9, root over of 9 is 3, so 1 by 3, 2I cap plus j cap plus 2k cap. So with this we are having the unit normal vector to the surface at a particular point. Now let us come to the next problem. It says that find the directional derivative of the function f of xyz equals to x square y minus 2xz plus yz square at a point 1 comma 1 comma minus 1 towards the direction of 2I cap minus j cap plus k cap. How to find out this? Already I have told you in this video lecture that how to calculate the directional derivative. So for the formula of the directional derivative we need to calculate the gradient of f. So grad f equals to I cap del f del x plus j cap del f del y plus k cap del f del z. So we have differentiated x square y minus 2xz plus yz square partially with respect to x, y and z. After doing this we get I cap into 2xy minus 2z, j cap x square plus z square and k cap into minus 2x plus 2yz. Now this grad f we have to calculate at a particular point 1 1 minus 1. So we are calculating grad f at this point 1 1 minus 1. So the result is coming as 4I cap plus 2j cap minus 4k cap. Now if you remember the formula, so we need to calculate the directional derivative of the function this towards the direction of a unit vector, but here 2I cap minus j cap plus 2 plus k cap is not a unit vector. So basically we need to convert it into an unit vector by dividing with its magnitude. So what is our a cap? 2I cap minus j cap plus k cap divided by root over of 2 square plus minus of 1 whole square plus 1 square. So it is coming 1 by root 6 2I cap minus j cap plus k cap. So what is the formula for finding the directional derivative? That is the unit vector will be dot product with the gradient of f at that particular point. So a cap dot with grad f. So this is our a cap. Just we have find out this, and this is our gradient of f. So we have just taken the dot product of these two vectors. So for dot product I dot I, j dot j and k dot k, these are going to be 1, and other components dot products are going to be 0. So after calculating, the result is coming as 2 upon root 6. So this is the way we can calculate the directional derivative of any scalar point function toward a particular direction. Let us come to the next problem. So it says that in which direction from the point 1 1 minus 1 is the directional derivative of the function f of xyz equals to x square minus 2y square plus 4z square is going to be maximum, and if it is maximum, then also calculate its maximum value. So these are the two things that we need to do in this problem. So first of all, we have to find out in which direction the directional derivative is going to be maximum. So basically the directional derivative is going to be maximum towards the direction of the vector grad of f itself. Okay, so we have to just calculate grad f at this particular point 1 1 minus 1. So the formula of grad f I have written, and we have calculated the grad f value. So it is coming I cap 2x minus j cap 4y plus k cap 8z. Now grad f at this point 1 1 minus 1, this is going to be 2i cap minus 4j cap minus 8k cap. So this is the vector along which, if we find out the directional derivative of this function, the function derivative will going to be maximized. Now what will be the maximum value? So the maximum value we can obtain by simply taking the modulus of this grad f quantity. So modulus of grad f is coming root over of 2 square plus minus 4 whole square plus minus 8 whole square. So this is coming as 2 root over of 21. So remember that directional derivative will be maximized in the direction of grad f, and the maximum value of the directional derivative will be magnitude of the grad f. Now sometime we face this type of questions also, which is another application of gradient in the scalar point function, that is the angle between the surfaces. So what are the things that we need to know here? What is the formula? Suppose we are having two level surfaces, phi 1 equals to c1 and phi 2 equals to c2, and both the surfaces are having a common point through which we can find out the angle between the surfaces. So the formula for finding the angle between the surfaces is cos theta equals to grad of phi 1 dot grad of phi 2 divided by magnitude of phi 1 into magnitude of phi 2. How this formula is appearing, the derivation I have not shown here. If you want, you can make some comment, then I can make a separate video for finding the angle between surfaces, how this formula is coming. Now let us apply this formula to the problem and to understand the question very easily. So let us come to the fourth problem. So we have to find the angle between the surfaces x square plus yz equals to 2 and x plus 2y minus z equals to 2 at a particular point 1 1 1. So from the formula just now I have shown you, we are having two surfaces, phi 1 equals to x square plus yz minus 2 and phi 2 equals to x plus 2y minus z minus 2. We have to calculate grad of phi 1 and grad of phi 2. So grad of phi 1, it will come 2x I cap plus z j cap plus y k cap, and grad of phi 2 is coming I cap plus 2 j cap minus k cap. Now we have to substitute the point 1 1 1 in this grad phi 1 and grad phi 2. So both the values are going to be 2 I cap plus j cap plus k cap and I cap plus 2 j cap minus k cap. Since in this grad phi 2 there is no xyz, therefore by putting this 1 1 1 or not putting, the value is going to be same itself. Now we have to calculate the angle between the surfaces, that is the cos theta formula. So grad phi 1 dot grad phi 2 divided by their magnitude and the product of the magnitude. So just we have taken the product of grad phi 1 into grad phi 2 dot product I dot I j dot j k dot k divided by the magnitude of grad phi 1 and grad phi 2. So finally the calculation gives us 1 by 2. So since cos theta equal to 1 by 2, so the value of angle is cos inverse of 1 by 2. The result is pi by 3. Now we are having the last problem for today's lecture, and this is one of the most important problem. Many times we have faced this question in the exams. So it says that we need to calculate the value of two constants a and b so that the surfaces ax square minus byz plus equals to a plus 2 into x and 4x square y plus z cube equals to 4, this to cut each other orthogonally at a point 1 minus 1 comma 2. What is the meaning of orthogonal cut? The orthogonal cut means that the surfaces are going to be perpendicular to each other, so the angle between the surfaces is going to be 90 degree. So if angle is 90 degree, so cos 90 degree is going to be 0, so cos theta is going to be 0 whenever they cut each other orthogonally. But before we come to the formula, we need to find out the gradient of phi 1 and gradient of phi 2. So phi 1 we have written and phi 2 also we have written, just taking all the terms on the left hand side of these two surfaces. Now we have calculated grad phi 1. This is the result of grad phi 1, and similarly we have calculated the grad phi 2, that is I cap del phi 1 del x, j cap del phi 1 del y, k cap del phi 1 del z. Similarly I cap del phi 2 del x plus j cap del phi 2 del y plus k cap del phi 2 del z. Now we have substituted the point 1 minus 1 comma 2. After substituting, grad phi 1 value gives us a minus 2 I cap minus 2 b j cap plus b k cap, while grad phi 2 will give us minus 8 I cap plus 4 j cap plus 12 k cap. Since these two surfaces cut each other orthogonally, so cos theta is going to be 0. So the formula for cos theta we know, grad phi 1 dot grad phi 2 divided by their magnitude and product equals to 0. So if we cross multiply, so mod of grad phi 1 grad phi 2 will be multiplied with 0. So on the left hand side only we are having grad phi 1 dot grad phi 2, this equals to 0 only. So you just take the dot product of grad phi 1 and grad phi 2. So result is coming minus 2a plus b plus 4 equals to 0. Now this is only one relation. How we are going to calculate the value of a and b from one relation? This is the trick of this problem. Always remember the point that at which we have to calculate the angle, that point should be common to both the surfaces. So this point 1 minus 1 comma 2, it lies on surface 1 phi 1 as well as phi 2. So if we substitute the point in the surface, it will satisfy the equation. Okay, so we have the phi 1 value as that you can see ax square minus byz equals to a plus 2 into x. So here we have substituted the point x equal to 1, y equal to minus 1 and z equal to 2. So from there also we will get one relation between a and b, and from here the value of b is directly coming as b equal to 1. After getting this value, we have to substitute this b value in the previously obtained relation. From there we can get the value of a, and a value is coming as 5 by 2. So these are the two values of the constants for which the surfaces will cut each other orthogonally. So with this lecture is going to end. Next lecture I am going to discuss about the divergence and curl of a vector point function and its application. Thank you all.